Good morning, ladies and gentlemen. I hope you had a good sleep last night. Some of us stayed a little bit late in this legendary Club C. And I think you had a good time. I only heard that there were several complaints about the excursions yesterday. So is there anyone who liked the excursion yesterday? Okay, so I misunderstood something, I guess. So welcome at the last plenary sessions meeting. Let me first introduce our first keynote speaker, Marguerite Trocmé. I guess many of you know her, but still I will introduce her briefly. She is a biologist, specializing in terrestrial ecosystems, but she also received a diploma as an environmental engineer, specializing in soil science and ecotoxicology. She worked for World Wildlife Fund and also for the Swiss Ornithological Institute. But from 1989 until 2007, she worked as in the Swiss Federal Office of the Environment, reviewing the impact of infrastructure projects on nature and landscape. And she began specializing ever more on transport infrastructure issues, participating in the first fauna passage projects in the early 1990s and in launching the Swiss defragmentation program. This finally led her in 2008 to move to the Federal Road Office in Switzerland, taking the position of head of environmental technology. And she is involved in many applied research projects, the latest on biodiversity-friendly mowing machines, utilizing AI for censusing invasive plant species, and she has initiated many environmental guidelines for roads. So I would like to welcome Marguerite Trocmé to tell us of something about her 35 years of experience. Marguerite, it's yours.
Thank you. Well, it's a great pleasure to be among you this morning, and I propose to look back a little bit so that we can look forward even better. And it was quite a challenge to prepare this talk. And I was thinking, where did this all start? So the chapters I will go through are: how did I fall into road ecology? How did road ecology evolve from the 80s to today? First guidelines, understanding the life cycle approach, integrating verges as road assets, and looking at ecological compensation measures and their limits. And in conclusion, the main lessons. So how did I fall into road ecology? It's, I guess, a long story. Tomasz kind of already showed it. You don't train to be a road ecologist. Most of us probably never dreamed of it. It kind of just happens. I mean, is there anybody here that has trained to be a road ecologist? I thought so. Well, looking back, I realized that maybe my career started before I could actually read and write. I think at 6, a first attempt at traffic calming. I used to live on a very busy street, and I wasn't let out alone, of course. And we moved when I was 6 to Canada. And my father tried to explain to this little 6-year-old, what is Canada? So they live in igloos, and the street we're going to live on has so little traffic, you can actually sleep on it and you will not be run over. I took that very seriously. So when we arrived in Canada and I saw a house, apparently I broke out into tears. Where's the igloo? And when my parents turned their back and they were getting all the boxes out of the truck, I lay down on the street, of course. And that didn't go well with my parents. They said, don't ever do that again. So I decided not to join Extinction Rebellion. So the first environmental issues with roads started very soon after they were built in Switzerland. The first highways stretch were built in 1955 near Lucerne. And I don't know if you can see, you have to sort of really look at the cars on that. I think we can count 5. But the first standards, actually environmental standards, go back to 1968. They're wildlife fence standards. We have an association of engineers in Switzerland called the Road and Traffic Engineers. And yes, so they date back to that time. And the road network planning so started in the 50s and went on to the 90s. Yeah, we're slow in Switzerland. So we built 2,200 kilometers over all this span. Why are we so slow? Because of our direct democracy. And if you look on the left side, you can see that from the very start, even before impact assessments, we were not sure what alignment. The farmers didn't want any highways. Many towns didn't want any highways either at the very start. They were afraid of the nuisance created by them. And so it was very difficult to find the right alignment. And then, as of the 60s, the NGOs got to say. And so, for instance, to the right, the first alignment of this A1 highway was supposed to be in the wetlands along the Neuchâtel Lake, and there was a lot of opposition, and luckily it got pushed back into the hills behind. So just, you know, when we were building roads, where did we start, or what has happened? So in Switzerland, the first environmental legislation actually goes back to 1902 with the Forest Act protection. And then Nature Protection Act came in the 60s, and the Environmental Protection Act, which consolidates the polluter pay principle, so that mitigation was to be paid, for instance, by the roads, only came in 1983 with the environmental impact assessment and necessity and report, and the assessment of the assessment report. But it wasn't until 1988 that the ordinance came through, meaning the ordinance defined what infrastructure would need an impact assessment. And so this is why the first impact assessment started in 1988. I was hired in 1989 to assess the impact of these statements on so looking at the first impact reports and following them up on infrastructure. Look at this way, here we go. So I started with high tension lines, pipelines, dams, railways, aviation facilities, and roads. So the first impact statements date back to '88, and at that time there was no methodology and there was hardly any data. And we actually looked towards France, so I'd like to thank my French colleagues, because the first fauna passages were built in Alsace in the Hart Forest, and so we're looking at that. And if you look, I think, you know, already back then there were some very good biologists, Guy Berthoud, on the Swissoise Jean Carcignol in France, who were already looking at the wildlife corridors, looking at hunting data, looking at actually landscape models, and looking at the alignment, where could animals still cross, and where would fauna passages be needed. So we were developing these mitigating tools, and at that time, and it still is, exchange of knowledge was vital. I had the fortune to participate in the third, actually, exchange of knowledge in France on roads and wildlife. Our first handbook came out in 1998 and it was really interesting because it was an engineer that got together, Steve Muller, with a biologist, Guy Berthoud, and designed sort of the first fauna passage, what they could look like. Then we had the COST 341 program, which helped exchange knowledge, look at good practice, and that came into IENE. And it's been very precious. So the first planned Swiss fauna patch date back to 1988. But when the engineer said, okay, so we do a fauna passage here, but what dimensions? Well, the biologists could not answer. And actually the very first fauna passage, the planned one, went through the courts, all the way to the High Court, because the NGOs wanted a more than 100-meter wide fauna passage, the one to the right, because the very first that was built was in the eastern part of Switzerland, and the engineer decided he's not going to wait on knowledge and biologists telling him how wide. He had a tunnel that with all this material coming out, and he just decided, well, I can use all this material from the tunnel to make this fauna passage, and it'll have to be 120 meters so I can use all the material. That's how the first width was decided. It's because we had enough material out of the tunnel. But the NGOs thought that was now the new standard, and luckily Germany had launched a study through Europe of 12 passages over 3 years, looking at the utilization, the frequency, and the spectrum of species. And it was found that as of a 50-meter width, there was no net gain. Costs immense, but no net gain in utilization. So that became for us the standard, and since then we haven't had a fauna passage have to go all the way to the federal court to be accepted. So planning has become much more efficient. So back then, mapping, censusing habitats, we didn't have the data we have today, and it meant, and now it looks like a luxury, that we had 2 to 3 field seasons to go out and map, look at species, look at vegetation, look at what were the issues. And today, most often, if you have one good field season, you're happy with your impact assessment. So looking back, we had time that no longer seems to exist. And what I found interesting was, so I was looking back at these old impact assessments, is that even then, we were looking at not only the negative impacts, but what could possibly be the opportunities with this new infrastructure. Can we actually benefit? Can we use the passing of the infrastructure to make something better? I'll come back to that. So on the basis of the European handbook, we have actually in the last, 10, 15 years, developed 8 different guidelines having to do with biodiversity. And really the guidelines and the handbook, the COST handbook, has really helped to create a common language between engineers and biologists. Just a little example. If you say to an engineer, well, at the beginning, say, it's got to be 50 meters wide, then the engineer looks at you and says, yes, but the highway is only 30 meters wide. Well, you're not talking about the same width. A bridge or a tunnel for an engineer, he measures the width of the highway, and we're talking about the width for the animals. So just simple things like that. We have to get together there and be sure we're talking about the same things. Helping to integrate wildlife specialists at the very beginning of the planning phase, that's today the case, but it wasn't the case at the beginning. Giving clear technical description of mitigation solutions so that engineers know what they have to do. And by the way, all our standards you can find on our website. If you Google Astra standards, you will find them. So today, a wide palette of mitigation measures are applied. I'm sure in the different presentations you have seen them or will see them. Underpasses, overpasses, amphibian tunnels, small mammal tunnels, etc. And the monitoring of the effectivity of these measures to improve the mitigation is very important. And I had the pleasure of just about 10 days ago to be out in the field and look at some very new overpasses that were opened a year or 2 ago. And we are now looking also at monitoring bats. And it was very interesting to see that there were many more species using the overpass than actually we found in the surroundings, so that there's really this effect of attracting animals to pass over the highway safely. And another really interesting fact is it was just by lucky, there was a collared radio-tagged red deer eastern Switzerland. And as I said, this overpass has only been open for about 2 years. And it actually came, so this is in western Switzerland, or middle Switzerland near Lucerne, and it came all the way, came over the overpass, went towards the Jura, decided he didn't like it so much apparently, and went back the same way. And that was really exciting to see the long range, the long range movement of fauna. So it's not just the local, but we're really hitting that long range movement again. So at the start, we were really focusing on mitigating this new infrastructure. So, getting animals to pass, compensation measures. But we were not thinking of the global fragmentation, and it really became in the late 90s a major conservation issue. And we have on the lowlands in Switzerland one among the densest transport infrastructure. And so we developed landscape permeability models. With the Alps, obviously, we have natural barriers and many infrastructure barriers. And when I was studying biology, you talk about inbreeding and the consequences, but I'd actually never seen the consequences myself until this year. This is a photo trap of a lynx that has no ears. And we know that certain lynx populations, they're all isolated, have actually crashed in the past few years in certain countries. So this, the impact of fragmentation is very heavy for certain species. So from the EIA, getting the first roads with impact assessments and mitigation, we're now looking at retrofitting existing barriers. So we have we've designed with landscape models and knowledge from movement of animals, 303 supra-regional corridors, or the long-distance migration, and only 28% are intact, 56% are impaired, and 16% are disrupted. It's a little bit better now because we have actually now started retrofitting. And to the right, you see the number of fauna passages we have today. Some are linked to those first highways with mitigation measures. Others have to do with widening of highways and retrofitting then, and others like this one. This is a new fauna passage built over existing highway, built under traffic. So defragmentation is happening. And from the big picture, we started to realize that many details are also essential. This is an example of a road runoff tank, and some of these can really catch thousands of amphibians in which they die. And so among the standards is always have an escape ramp, so they're all equipped so that amphibians, if they get washed into this, can climb back out. Or another important detail, if you have transparent screens for noise mitigation, avoiding stripes to avoid collisions. And this is also where research is so important, because the density of the stripes is not just some wild guess. It was actually really, there's been research done on birds with wind tunnels and looking at different density of stripes. And this was found to be the most effective to avoid collisions. Again, so science helping practice, very important. And this is looking, work has to be fun, and sometimes it's real fun. And this is one of my favorite experiments, so mitigating noise screen impacts. So especially along the railway, we have very important, because of the ballast, lizard populations, reptile populations. And when we build noise screens, these populations will get cut off and disseminated. So there has been that the reptilian specialists have proposed certain types of mitigation, but they had never been tested. So this little project was here to test the mitigation measures. So we first, we radio tagged a number of lizards, and we did translocation experiments. And the first question, is the railway itself a barrier? So a male was captured, that's the white point, and brought to the other side of the railway, that's the red point. And the whole population, basically females, stayed on the other side. Within 15 minutes, this little guy went back over. He was not going to stay alone without the females. So no, the railway is not a barrier. But the screens, noise screens are, and so you see at the base, we've put in gabions, and with the assumption that reptiles can go through it, but it had not been tested. And so again, we did a translocation experiment, taking a lizard from one side to the other. And so here it was taken from these gardens on the one side, put onto the railway side. And it took a little while to figure it out. He didn't cross back there, nor there, but here, over he went, through he went, oops, and started coming back to his original spot. So science to help really prove that mitigation measures work and improve them. So we started with planning and building new infrastructure and getting those guidelines out, retrofitting, but we weren't thinking enough at the whole life cycle, maintenance. And so now when we get the guidelines out, we try to really think of the whole life cycle, because if a measure works at the beginning but it's not maintained properly, then after a while it's lost. And CEDAR had a very nice research project on that, looking at the life cycle and how to maintain assets, ecological assets. So now when we revise any of our, or put out new guidelines, we always have principles for every type of phase of the infrastructure, because we're not talking to the same people. So principles for new roads, avoidance obviously, permeable alignment, multi-use structures, fauna-specific passages. But when we're widening a highway, it's sometimes not the same engineers, and so we have to tell them, you're going to retrofit for important wildlife corridors, that's going to be the main, and then improve longitudinal connections along the verges, and adapt existing structures for multi-use by fauna. And then upgrading again, it's not necessarily the same engineers, so you're saying you want to reduce fragmentation by improving existing structures and add fauna-specific passages at major wildlife corridors. And I cannot say how important the transfer of information is in the life cycle. So just a month ago, I was asked to go out and see these weird structures that the people who were doing maintenance had no idea what this could be. Is this drainage? I said, no, that's a forgotten small fauna passage. Had not been kept up, almost completely invaded, not only with grass, but inside there was a lot of soil that needed to be. And this is really, I think, one of the most difficult things when you're looking at any kind of infrastructure, is to be sure that the information goes from one person to the other. So one of the ways we're trying to improve this is by putting the information having to do with our engineering structures, our crossing structures, in our data bank. This is an engineering data bank, and it had no, for instance, that very first fauna passage I showed you a picture of, well, it was in the data bank, it was just, okay, this is a bridge. But It was not said that it had a purpose for fauna. So putting that information in, so now that all engineered structures, crossing structures that have some purpose for fauna are labeled that way. So we have the attributes in there that are, and we're not only looking at specific, but also over structures that have a potential use for fauna. And we did a SIG analysis of all our crossing structures to see which ones could have a potential for fauna as crossing structures. So over our highways, we have 4,474 crossing structures, overpasses, underpasses, culverts, what you name it, and deemed that 65% actually could have use for fauna. Mostly culverts, if you look to the right, mostly bridges and viaducts, and some overpasses, some underpasses. This is what it looks like. You can have a viaduct. It was built for topographic reasons, but animals can cross under. An underpass, an overpass here with a small green stripe, and bridges. So the hope is to avoid mismanagement through proper data transmission. So if you look to the left, here we have a viaduct with tree stumps and big rocks so that people can't go and just deposit any kind of things underneath it, and it's still functioning. And to the right, well, what we call in Switzerland Baupolizei, so you could call it the building police. They get requests from mostly people from agriculture. Can we deposit our machines under the viaduct? And the guy said, yes, sure, but you have to fence it in, otherwise it's dangerous. So that was supposed to be for fauna. Well, it's not being used anymore. And we really need to avoid these situations. So next step was really realizing that, and this is why it's interesting to be a biologist working for the roads, is you understand the mechanisms of how things work. So, you know, the engineers go out and they look at how the bridges are doing, how the pavement is doing, so they do road access inspections. But we weren't doing this for ecological, for the verges, for instance. And so with my engineer colleagues, we said, well, we need to be doing the same thing we're doing for bridges and pavement and et cetera, also for our ecological assets, looking at the quality. Whoop. So, well, I guess that, here we go. So we're promoting biodiversity on roadside verges. This is most of the case when we plant. We use native seeds, slow growing shrubs, extensive grasslands. However, if the picture with the beautiful flowers, if you go there today, you won't find one, because in the past 20 years, it's been mulched. It's gone. So we have to be careful that management really takes care of these areas. So we're defining now, putting aside 20% of our verges as biodiversity hotspots, so that verges that have wildflowers are managed properly, and other ones we can maybe put more little structures in there for wildlife. And then really showing, so there's a little post with a flower, that's to show the beginning of one of these biodiversity hotspots. So when they do the mowing, let's say in the spring, they know they stop here and they wait for the next post, and they won't mow that area before August. So it's really showing the maintenance people where these spots are. And so looking at the inspection of green assets, we're using the same type of approach as for any kind of engineering structure. So it'd be every 5 years, an inspection looking at the physical state of the verge, the ecological function, and how we train the maintenance personnel, because that is actually something we also want to look at. And good to bad. And using very simple criteria. So for instance, number of species, we're not looking at the actual species, but the number of species. Okay, and you'll find more on internet. And then new maintenance guidelines, And we need new tools because we realized, and this is one of the research projects we have going on with our German and Austrian colleagues, is mowing machines today are not adapted for biodiversity. They're mulching, we need other machines. So this is research, and we hope we will find some interesting new results. So first, studying the impact of different types of mowing regimes on fauna and flora and different types of machines. Using new tools, AI to sense invasive plants along highways. There's been a really interesting presentation on that. We've mapped our network for 2 species to see where the hot spots were and to try to prepare a better strategy. So, key to promoting biodiversity on roadside shoulders, I'm not quite at the conclusion yet, but I just want to stop here a moment, is really the clarity of the guidelines for the users. Be aware of security issues. Make implementation easy. You have to remember, whatever's happening on the verges, it's on highway verges or road verges, and people are exposed to traffic. It's a dangerous job. It's going to need sufficient budget. There will be more handwork. Try to prioritize. We're using these biodiversity hotspots. Adapt the machinery. Train your maintenance personnel. Monitor and adapt. And especially communicate to the public, why are the verges looking not so well maintained? Well, they're actually better maintained, but for biodiversity. So last is ecological compensation measures. Are they a success, or has it all been a false promise? So at the very beginning of those first highways, actually we're going through intensive agricultural areas. And so we had really looked at trying to recreate green infrastructure with hedges, etc. A lot of little measures, and turned out very complicated in implementation because you had to negotiate with so many different farmers, and many did not survive time because the farmers, even they said, yes, yeah, we'll keep them up, well, didn't. But measures covering a more important surface have done actually very well. And in this case, this was an old gravel pit that we revitalized, and it's now a site of national importance for amphibians. Very important was, from the start, was also looking at how are we going to finance the maintenance of these ecological compensation measures. Polluter pay principle. It was decided, obviously, that the highways were going to have to finance it, but we weren't going to do the maintenance ourselves. So we pay the local, regional nature protection organizations to do the maintenance. They have the knowledge. We're not nature protection organizations, but they get a lump sum to do the maintenance. And this is also has been a really nice surprise. Well, surprise. Just about 2 months ago, I visited one of these very first ecological compensation measures out of the late 80s. And not only has it thrived, but we have new species in there like beaver. It wasn't even in the goals in the late 80s because the beaver wasn't even around at that time. And now a step back, and I'd like to show you 2 examples. One example of a landscape where the highway was built in the 60s, and there was no impact assessment and no ecological compensation. So this was an intensive agricultural area. In came the highway. In came all the industrial areas. This is what it looks like today. If you find 5 bird species, you're lucky. This is another area, highway coming in, impact assessment, ecological compensation, also a golf course, alas, but also with ecological compensation. Used to be rather extensive agriculture. And with the highway, we've planned, plus the golf course, a lot of extensive agricultural sort of typical measures. So this is the highway. These are now preserved, extensive agricultural areas. And so we have buffered against urbanization because industrial areas were encroaching. So this is what it looks like again now. And we've got 60 bird species breeding in this area, and many quite rare. So to move to my conclusions, I think we need, and probably more of us would think of us as connectivity conservationists than road ecology. We need to move beyond road ecology and look at how we can preserve nature in a dynamic landscape. What did we do right? What are our strengths? Well, what we did right is definitely the fact that we're here today, share experience between countries, learn from each other, develop a common language and understanding with engineers is essential, publish road ecology standards where the engineers will find them, because the very first guidelines were written by environmental ministries and they were on their platforms, but the engineers were not even looking at them. Science-based practice. Trial and error approach is also needed, so be careful with science-based practice. I'll use the term of Vincent O'Malley, don't do catch-up, that is gather knowledge, but not be able to put out there in the field. He'll explain that better to you later. Monitor fauna passages to improve their activity for multiple species, and those NGOs are so important to make policy advance. So those who are in NGOs, thank you. Weaknesses. Loss of information between each life cycle step, from planning to building to maintenance. That's a main weakness. Lack of overview, lack of data banks. Information missing from these data banks. Administrative hurdles, everyone or no one is competent for that question. Too little cooperation, complexity of decision levels, lack of finances. Spatial planning. Spatial planning is a main weakness because it does not integrate impact assessments. All those industrial areas have never been submitted to an impact assessment. So the main risk is no limits to growth. And in front of us in Switzerland, we've gone through 3 cycles, I would say, of intensification of our landscape. The first was agriculture. The second is transport and industry. And now we're going into the third tidal wave with energy production up in the high Alps with turbines and photovoltaic parks. And we don't know where that's going to lead us. So to finish, I'd say to the left is often what was left of nature in Switzerland. And yesterday we had a wonderful example in Czechia, how you can give space back to nature. And thank you for your attention.
Thank you, Margaret, for your very complex presentation, bringing us back to history and showing also the future challenges. Thank you. And we have a couple more minutes for your questions or comments. Yes? Oh, wait for the microphone, please.
Sergej Bogaerts from the Netherlands. You talked about nature compensation and paying off the NGO with a lump sum for doing maintenance. Does that work in the end? Because you need long term. So what's long term and how do you finance that well enough?
Yes, it works because it's not NGOs, it's really the state nature or organizations, sometimes NGOs. It's a contract which is renewed every 5 years, and there's no, the life cycle is as long as there's the highway. So every 5 years is a lump sum.
Any more questions or comments?
Hello, Mauricio Camargo from France. Thank you very much for this very interesting overview of your experience. You mentioned something that is, for me, very important is training people and getting people from the ground, technicians, operational people, I mean, is more and more difficult for administrations, also for companies. So how to get people interested in this fundamental issue?
This is something I wanted to stress. You really have to get out of your offices. So every time I write a guideline, I first spend time talking to the people out there actually doing the work and trying to feel where their problems are. So it's, I was talking to somebody in the bus yesterday. I said, you know, when I started my studies, I was not hesitating between biology and psychology. I did 6 months of psychology. It's probably been the most important 6 months in my career, because it is really feeling people, talking to them, connecting, and being able to resolve conflicts. And I can't say, you know, there's no recipe, but going out and talking to people.
Thank you. So the last question.
Hi, Marguerite, my name is Thomas Schuh from ÖPB in Austria. Thanks for a great presentation and to show us your achievements of the last years. You mentioned the polluter pays principle for several times, so I would like to ask you, who is the polluter in this case? Is it the motor, is this the highway administration, or is it the car and truck drivers that you take to finance your measures?
So it's obviously both. So that the roads are paid by the car drivers. There's a tax on fuel, and we're having to replace that, see how we're going to finance that with e-cars. But the motorists pay for the highway, and the highway pays for the mitigation measures. I don't know if that answers your question. So, yeah.
Okay, thank you. Thank you, Margaret. Thank you for your answers, for your questions. And we move further